Welcome to the course Business Analytics and Data Mining Modeling using R. So we have reached to our last part of visualization techniques. So in the previous lecture we had started our discussion on specialized visualization. So we will continue from there. So in the previous lecture we started an exercise on network graphs, that is for network data. So we will start from there, and then we will cover tree maps, that is mainly for hierarchical data, and then map charts, that is for geographical data. So till now what we have been mainly dealing with before specialized visualization was mainly cross sectional data or time series data. Now these types of data set, network data, hierarchical data and geographical data, they are for different specialized visualization, and they have different kind of data set as well. So we will discuss them in more detail as we go along. So let us open our studio. So for network graph we are going to use this network data, which is mainly, as we also talked about a bit for this in previous lecture, that this is mainly in association rules context. If we try to have, we need to understand a bit more about association rules. Now association rules, they are generally the association rule mining is generally done on transaction databases. So generally transactions are in this format: transaction ID 1, 2, 3, 4, and then items. And generally when a customer visits to a retail store, generally they purchase a few items. So let us say these are those items that were purchased by the first customer, that is reflected in transaction ID 1. Another customer might purchase C, D, another customer might purchase D and A, another customer might purchase B and D. So there are 4 items that are available, that are mainly under discussion for these 4 transactions. So they are being purchased by different customers, and transactions are being recorded. So in each transaction which items have been purchased, you can see it here. So if we are interested in finding out, generally association rules mining is about finding out what goes with what. So more discussion on association rules we would be doing in a much later lecture, when we will devote much more time on association rules. Right now we can understand what association rules is about, what goes with what. So we try to identify which item is being bought along with which item. So we are interested in finding out those items so that we can plan our store layout and other things, promotional offerings and marketing offerings. We can bundle some of the items to boost our sales. So those kind of things can be done if we are able to identify. Now in this particular case, when we are discussing network data or network graph, we are interested in understanding transaction based data, database data set in a particular format, where we are interested in finding which item was purchased first, and then another item would be purchased after that in the same transaction. Similarly for this one, C, D, D and A, and B and D. So this particular information can also be depicted. This particular information can also be depicted in through a network graph, and we can understand from there. We can make some sense about, if we are dealing with large amount of data, then in that large amount of data, visual analysis can be really helpful. So there we can, so right now in this example that we are just doing, we have just 4 observations, 4 items, 4 transactions, 4 items. But if we are dealing with large amount of data, visual analysis, visualizing the data in a network data format, in a network graph, right, would be much more helpful for us to understand what is happening, which items to identify, to be able to identify some patterns, and then that can be really helpful for us in our association rules mining. So we will just do that. So what we are going to do is we are going to create bipartite graph, that is 2-mode graph. So in this case, as I talked about, item 1 in a particular transaction and the item 2, the second item that is being bought, that is being purchased in the same transaction. So there are these two types that we are going to create. First, let's create the network data. This is hypothetical data we are going to create. So let's say we have letters 1 to 10. So that is, let's execute this particular code. Letter A to letters from A to J. So these letters are representing different item, right? So let's execute this code. Let's create this pool, item 1. So these are the items that are being purchased in different transactions. Now second one is, because the number of items are same, so we are using the same items, but in lower cases. This is mainly for the quoting purposes. Otherwise, whether the item is represented in uppercase or in lower case, they both mean the same item. It's just that we want to differentiate between what was purchased first and what was purchased along with that first item. So because here we are trying to create a data set where if an item has been purchased first, it should not be, because there could be multiple quantities. A particular customer might be buying more than one item of this or more than one item of this as well. So we are not interested in the quantity, we are interested in finding out if A is bought, what is the second item that is also being bought or purchased along with this, right? So that is why we need to exclude this in our coding. So let's create this variable item 2, and you would see I am running this loop from 1 to 50. So 50 observations are going to be created just like item 1, right? But because the same item cannot be depicted now, right? So it cannot be A and then second item cannot be, right? Because we are trying to get hypothetical data, we don't want this kind of situation, right? We want it to be something other than, so it could be from B to J and it should not be A. So that is what we are trying to do in our coding here. So you would see this item 2 lower item 1 I, and it has been converted into the lower case, and then we are comparing it with the pool items. Pool items are these. So let's create pool items. So these are the pool items A to J, smaller cases, and then we need to eliminate this when we do sampling for item 2. So that we get a proper item 2 vector. Now let's create the data frame of these two variables. You would see data frame has been created, 50 observation of two variables. Now iGraph is the library that is generally used for network data and network graphs. So let's load this library. Now from this data frame we are trying to create the graph. So this is the function that is being used, graph from data frame, and because this is not a directed graph that we want to create, right? So therefore directed has been assigned as false. So let's execute this. So you would see that G has been created in the environment section, and this is undirected graph. Now labels of these vertices, if we at this particular time, if we look at the details of our graph, you can see G, and you would see that there are 20 vertices, and in 50 observations are there, and then the 50 edges are there. You can actually see the edges. So these are different items. G and D was also bought along with this, then E and J, then D and C, and then H and J. So this kind of list edges you would have. Now let's rename these vertices. So they can be renamed after using their name itself. So let's execute this line. So this is done. Now as we said that we are trying to create two groups because we want to create bipartite graph. So therefore we need to have two groups. So that is being done through this type variable, right. So VG and the type is type 1 is actually for item 1 and the type 2 is actually for item 2. So we want to create two different groups so that we are able to create a network graph later on. So let's do this. Now we are trying to create a network layout. So how the graphs are going to be depicted. So we will be doing that. So we want to create our network layout. So all these items are going to be represented by some vertices, maybe in circles, and this is like type 1 and type 2. Type 1, this is actually for item 1, and type 2, this is for item 2, right. And so these are like these elements, so represented by these elements A, B, C, D in this fashion. Similarly A, B, C, D. So A could be with C, C could be with D, depending on the transactions that we have. So this kind of network graph we want to create so that we are able to visualize the data. So right now using X and Y coordinates we are trying to create we are trying to generate coordinates for all the vertices. So run if the command that we are going to use. So you would see that we are trying to create 10 because there are 10 items, right, in type 1, and similarly 10 items in type 2. You would see that run if 0 to 5 is range has been given, and here 10 to 15 range has been given. So some space between these two groups, because this is a bipartite graph, some space is being left in the layout, right. So then we can easily visualize these vertices or nodes. So this is for X coordinate. Y coordinates is, you can see that some spacing between different vertices or nodes is being plotted using sequence function. So once we have done this layout planning, now we can decide on the shape of nodes. So in this particular case we are going to select circle. So vertices, they would be in this shape. We can have squares and other shapes as well. So for this exercise we are selecting circle. Then there are going to be there could be many edges between two particular nodes. So if we are just trying to convert, if we are just trying to depict transactions, right, into a network graph, so there could be some customer who would be buying the same item, right. One again B and D, this kind of transaction could be there. So therefore between B and D there could be multiple edges. But in a network graph we don't want to show in this fashion. We want to show just one particular edge, but we would like to change the width of this edge. So this should be a much wider edge representing more number of connections, right. So this is that is how we want to show that. So we need to find out the multiple edges between two vertices. So this is what we are trying to do using count dot multiple function. So in a graph that has already been created with G, right, in G, so that we can find out, and we are trying to. So if we execute EG weight, let us see the values. You would see that for all these edges, the 50 edges that we have right now, you would see some of the edges you can see that for example, this one is twice, some of the edges are thrice, right. So in this fashion we can find out how many edges are between the same vertices. Now we want to remove these multiple edges. So this we can do using simplify function. So simplify function, you would see that remove dot multiple argument is there. So we are setting it as true. So that is going to remove the multiple edges. So let's execute this line. Now in the next line you would see that now we are trying to assign width that same weight, because we want edges to be of much wider width where the multiple edges were there. So the same thing we are trying to assign it here. So you would see EG1 dollar weight that has been assigned to EG1 width, and 0.5 is the kind of we are trying to control the scale of it, so that the network graph it is visually more pretty or attractive. So 0.5 is the direction is scale that we have done from our side. Depending on the way graph is being generated, we can change this. Once EG1 once simplify has been run, if you are interested in finding out the this particular weight, you can see the same. You can see there are many edges for which the weights value have increased, right. For some are 9 is also there, right. So there are many edges for which weights value have increased. That is because we have removed the multiple edges and increased the width and through weight. Now the same exercise we can do for the vertices. Now the size of vertices, that is also going to be based on the number of edges that are coming into coming into this vertices or going out of a particular node or vertex. So the same thing we are trying to do here. So for every vertex we are trying to find out the length, right. So let's execute this code. You would see that now this 4 here is again the boosting factor. So size, so that again the vertices they are they have the particular shape which is reflecting the number of edges coming into it or going out of it, and also the item that are being represented by A to J in capital letters or small letter, they are also very well seen. Now let's come back to the color. Two colors we are picking. So for vertices are going to be colored with gray color, and edges are going to be colored with black. So let's do this. Now let's set our parameter function margin 0.1 on all sides, and let's plot. Now let's zoom out this particular. Now this is our graph. Now from this graph you can see that items G and D which are in which are having much greater size, right. Similarly E and H. So there are many more edges coming into these vertices, right. You would see some of the edges, their width is much higher because they are involved in more number of transactions. So for example E and I, the width is quite high in comparison to other edges because these two items have been bought more often. So the same is reflected in the network graph. So from here you can understand. Similarly C and E, you would see that a smaller E, this is also the size of this particular vertex is also on the higher side. So you would see E is anyway involved in more number of transactions in the hypothetical data set that we have generated, and C and E, they are being purchased together many times. That is reflected in the through the width of width between C and E. If you want, you can have a look at the data frame that we had created for this particular exercise for network graph, that is DF5. The same thing would be reflected in these transactions. So, for example, in the graph, as we can see, C and E, there seem to be a more number of transactions, and E, there again being purchased many times. You might see that more often. You can see transaction 15, this particular record CE is there. You can see C in many transactions, for either in the item 1 or item category. Same case is there for E, and CE can also be seen in many records. You can see this is again, we can see C and E. So, the same thing we can verify here. Now, let us move to the next specialized visualization, that is about hierarchical data. So, sometimes we might have to deal with data that is more of a hierarchical, more hierarchical in nature. So, there are going to be, for example, in a university there are going to be departments, and within departments there are going to be labs. Similarly, in business organization there are going to be organization different verticals, and then there are going to be different departments. So, the way this particular information is going to be presented, it's more in a hierarchical format, right. So, how we can visualize hierarchical data, and how the kind of insights that we can generate through visual by applying visualization techniques. So, that we are going to cover now. So, interesting plots that can be used to understand or visualize hierarchical data is tree maps. So, we are going to generate tree map through an exercise. So, we have this data set e-commerce.xlx. So, let us look at the data first. So, again this is also a hypothetical data set. You would see there are 5 columns in this particular Excel sheet: item category, then subcategory, brand, price, and rating. So, you would see that item category we have electronics, furniture and clothing, and then subcategory within electronics we have mobile accessories, computer accessories, wearables. In the furniture we have subcategory within living room furniture, dining room furniture, and bedroom furniture. And then clothing we have for clothing for women, men, girls and boys. So, you can see for every category there is going to be a few subcategories. So, easily a hierarchy can be seen in the data. Then brands are there. So, of course, for every subcategory there are going to be multiple brands, and so there another hierarchy, and for each brands there are going to be different products. So, we are not covering the products here, but for each brand we have given some prices which are actually reflective of different products that are there. So, for each brand we have some prices and ratings for. So, these ratings are by customers. So, that is also available. So, we are going to use this particular hierarchical data, and we are going to plot tree maps and see what we can understand from those maps, especially about the data and how it can help in different tasks like prediction, classification and clustering. So, let us import this particular data set. Let us load this library first. Once the library has been loaded, let us execute this line and import the data set. You would see DF6 has been imported, 30 observation, 5 variables, the same Excel file that we saw just now. Let us execute this line as well. Let us look at the structure of the data set. You can see item category, factor, subcategory is also factor, and the brand, and then we have 2 numerical variable, price and rating. So the library that we require for Treemaps is this Treemap library. So let's reload this particular library. So let's reload this library Treemap. So once this has been reloaded, let's look at the Excel file again. You would see that there are if we look at the price column, so there are few items in this particular price column which are of the very high value. For example, in the furniture, the values are from 20,000 to 90,000, right? The other items, other records that we see, they are of lower value. See in here it's up to 5,000, around 1,000, or even less than 1,000 other items. So there is quite a big gap between different price value, and when we are going to create tree maps, we would see that is going to impact the way the tree map is going to create it. So we want to reduce the scales of some of these values, especially for creating for the purpose of tree maps. So in tree maps, essentially we are going to be creating different rectangles. Let's see through an example. So tree maps are generally in rectangular format. So this kind of a rectangular plot is going to be created. Then you are going to have item categories, right? Item 1, item 2, and then you are going to have subcategory for these items. Subcategory 1, subcategory 2, 3. Similarly, for item 2, there are going to be subcategories, and then for item 3, and then subcategories, right? And then depending on the way you are trying to define the size of these rectangles, rectangular zones, right? The way you want to color them. So the shade of the color and the size of these rectangles, that is going to convey some information that we will see through an exercise. But we don't want some of the rectangular regions to dominate and reduce these size of other rectangles, so that the visual perception is lost. So we don't want to lose on our visual perception of some of the smaller rectangles. So we need to control for that. So if there is too much of gap in the range for a particular variable, which might be used for sizing of these rectangles, then that could be problematic. So what we are trying to do in this particular line, rectangular size for any price value. So price is going to be used to determine the size of these rectangular regions in tree maps. So for any value which is greater than 5,000, so we are trying to reduce that particular value of value of that price. So this is in this fashion, 5,000, and then we are dividing the value by 10. So that is how the new value would be, and that would determine the rectangular size. If the value is less than 5,000, then we will keep the value as is. So let's create this particular variable. Let's also add it into the data frame. Now let's again reset our pair margin 0.1 on all 4 sides. Now tree map is the function that we are going to be used. So there are many arguments that can be passed, that can be used with this tree map function. If you are interested in more detail, you can find out here in the help section. You can see tree map, and you would see there are so many arguments that can actually be used to design your tree maps. So some of them we are going to use in this particular exercise. You would see that first argument is the data frame that we need to pass on to this function, that is our data frame is df6. Now the second is index. So indexing of a tree map is dependent on the this hierarchy that we have. So our hierarchy is item, then item category, then subcategory, and then brand. So that has to be passed on using a character vector. So this is what we have done. So index takes character vectors. We have created this. Then the second argument that we are using in this exercise is v size, that is size for the rectangular regions that are going to be created. So we have already created a variable rect.size for the same. So we have made sure that the sizes are in the appropriate sizes, so that smaller rectangulars, they are not overcrowded or reduced to insignificant size because of bigger rectangles. Now the another argument that we have is v color. So for this coloring of different rectangular regions, we are using this rating column that we have. So ratings of these different products can be is going to be used to create different shades of a particular color. Type is another argument in this function. Value is going to be used here. So value of you would see value of price is going to be used to determine the this particular tree map. Then aggregate is using mean. So mean values, they are going to be used for the aggregation. Color scheme is gray. So we are taking 4 labels of gray colors. Font size labels for different categories and subcategories depending on the hierarchy of the data. This we have given 11 for item names, 9 for subcategory names, and then 6 for brand names. So this kind of font size labeling we are doing. And the title, we are not giving any title, and legend, so we don't want legend for our tree map. So let's execute this particular function. Let's see. So this is the tree map that we have been able to generate. Let's look at. So you can see that there is one particular category, furniture, which is more dominant because of the higher value, as we thought earlier. So living, dining, and bedroom are the subcategory, and then the brand names you can see. Rectangular regions, they are based on the average price. You would see that aggregation is based on the mean value or average value. So that has been done, and so that is there. And the shading of this shading is based on the rating, right? So if a particular brand is rated highly by the customers, the color intensity is on the higher side. So if it looks more of a gray, higher intensity gray color, then therefore customers have rated that particular thing highly. More of light gray, they have been poorly rated. So the sellers of those items have been poorly rated. So you can see this tree map. Now let's move to next part, that is geographical data. So to depict the geographical data, we generally use map chart. So again we are going to use another data set. This is between this particular data set has information about internet, inclusiveness, and the corruption perception index, and we are going to depict this information using map chart. So let's look at the data set first. You would see we have one column. First column is about the country, so we have different country names here, and then their index about the kind of inclusive internet that they have. So this index is reflecting that. Then the corruption perception index is also there. So we are going to create a map chart depending on these index values, and we will try to compare how the internet index is there, and how the internet index are there for different countries, and the level of corruption that are there, whether there is any link between these two, that we are going to do through map charts. So let's import this data set. So R world map is the library that we would be requiring to create these map charts. So let's load this. So let's reload this library R world map. Once it is loaded, so we need to create a device which is suitable for generating map. So we are going to create two maps, so therefore 2 rows and 1 columns. So let's create this device. As you can see, one device is active. Now we are going to use this particular function, join country data to map. So the country data different indexes that we had in the data set, we are going to join them. So name join column, that is country, the column that we had in our data set. Join code is name, that is by the using name of the country, right. So data is available in this particular data frame df7. So let's create this. Now you would see 71 codes have been, so one code there was some mismatch, so that failed. So let's move on. So there is another function map country data. So this particular function is going to create the map. So a data map is going to be passed in, then the appropriate the respective index that we want to plot in the map that we need to create. The cat method is pretty, the way the colors are going to be this selected. Color palette is given 7 to 0. Then legend, we don't want legend, so let's execute this code, and you would see a map has been created in this particular device. Let's execute the another one. This is representing the corruption index. You would see another map has been created. Now you can compare these two maps. So the first one is internet. You would see the US and Canada, these two countries, they are in the higher intensity color, right. So they have higher inclusive internet, and they also have low levels of corruption. So higher intensity of color is reflecting low incidency, low level of corruption. So you can see that. So in this way you can actually visualize, for example, inclusive internet index for India. You would see, you can see the shade of this color gray, and if you look at the corruption, so this is in the lighter shade. So inclusive internet is there, but the corruption levels are not that much, and not at that level. You can see Russia, the inclusive internet is a much higher index, but if you look at the corruption, there are much more corruption perception in Russia. So this kind of thing. So we cannot, so from this we can actually, in general we can see that if the internet inclusiveness is on the higher side, we can also see that corruption perception is also, corruption is on the lower side in those countries. Some exceptions are there, for example Russia. So we will stop here, and in the next lecture we will start our discussion on dimension reduction. Thank you.